Hello, in this course we are going to talk about signal sources. Often the source of a signal is some part of the circuit you are working on, but for test purposes a flexible signal source is invaluable. They come in three flavors: signal generators, pulse generators, and function generators. Okay, now let's start with signal generator. A signal generator looks like in this image and can produce an accurate sine wave. And this is the reason why signal generators are basically just sine wave oscillators, usually equipped to give a wide range of frequency coverage, which means that you can change the frequency of the signal, but you can also control the amplitude. Usually this control of amplitude is made by using a resistive divider network called an attenuator. Nowadays, these devices as well as most test instruments are available in configurations that allow you to program the frequency or amplitude from a computer or other digital instrument. And now if you ask what's the purpose of a signal generator, well, these generated signals coming out from the signal generator are used as a stimulus for electronic measurements, typically used in designing, testing, troubleshooting, and repairing electronic or electroacoustic devices. Alright, now let's talk about pulse generators. Pulse generators, as the name implies, make only pulses. Pulse width, repetition rate, amplitude, polarity, rise time may all be adjustable. The fastest ones go up to GHz pulse rates. In addition, many units allow you to generate pulse pairs with settable spacing and repetition rate, or even programmable patterns. Most contemporary pulse generators are provided with logic level outputs for easy connections to digital circuitry. Now, as an example, a very simple pulse generator can be achieved using 555 integrated circuit. By using this device and some passive components around, we can basically build a pulse generator. Alright, here we are. This is a basic pulse generator. Basically it consists of three passive components. As you can see, we have two resistors and one capacitor that we didn't learn about yet. And of course, we have the 555 timer, the heart of the whole circuit. Now, if you come down here, you will notice that this circuit generates, or we can say outputs, a square wave with an amplitude of 10 volts at 240 Hz and with a duty cycle of 50%. Now, there is really no reason for me to explain how this circuit works. That would go beyond our scope. But I want to warn you that in the future courses, when we will need a pulse generator, we will use the one given by the simulator. And this pulse generator, or you can name it square wave generator, you can find it if you click on the draw, input and sources, and you will see add square wave source. Now if you double click on it, you will see that you can edit some elements here, like you can set the max voltage, you can change from square wave generator to be a triangle generator or a pulse generator. You can set the DC offset, the frequency, phase offset, and the duty cycle. Okay. Now let's move on with our course. As we've seen before, our simulator is kind enough to provide us not just a square wave generator, because when we went to edit the component and there was a drop down list, right? You could select basically what kind of signal do you want to output, like AC, triangle, sawtooth, pulse, or even noise. And this device that can generate all these type of signals is called a function generator, okay? Now, a typical function generator looks like in this image, and using this you can basically generate all types of signals starting from 0.01 Hz up to, let's say, 30 MHz. If you are curious how to build a function generator, you can take a look at this circuit here. Now, because we didn't learn about operation amplifiers, you probably won't understand how this circuit works, but don't worry because we will cover all this in the future lessons, okay?